Hello once again. This topic will be dealing with Karnaugh Map. Karnaugh Map is a method of simplifying Boolean algebraic expressions. This was introduced by Maurice Karnaugh way back in 1953. While it's true that we can simplify Boolean equations using Boolean algebra, there are other methods that we can use in simplifying Boolean expressions. So one of which is what we call the Karnaugh Map. So let's try to consider the function k is equal to a prime, b prime, c prime plus a prime, b prime, c plus a prime, b, c prime plus a, b prime, c prime plus a, b prime, c. To use Karnaugh Map, it would be simpler if the equation is in its sum of product form. We can rewrite this equation into the summation of a prime, b prime, c prime is equal to 0, a prime, b prime, c is equal to 1, a prime, b, c prime is actually equal to 2, a, b prime, c prime is equal to 4, a, b prime, c is equal to 5. We can also use Karnaugh Map from a given truth table. This Boolean expression can be represented using this truth table. The truth table represents the relationship between our input and our output. Here, this Boolean expression simply states that k is our output basing on the combinations of the three inputs, that is A, B, and C. Let's try to consider this equation now. Our input is equal to A, B, and C. And since there are three inputs that can be from 0, a combination of 0 to 7, and it's represented in Boolean numbers to be equal to 0, 0, 0 is equal to 0, 1 is 0, 0, 1, 2 is equal to 0, 1, 0, till such time that we reach 7, which is equal to 1, 1, 1. Putting our expression into the map is simply getting the combinations of the literals that we have in the expression. That is actually equivalent to the summation of 0, it will be equivalent to 1, 1 will be also equivalent to 1, then we have 2, then we have 4, and 5. The remaining combinations of our literals will therefore be equal to 0. We can put the content of our truth table and our Boolean expression into our K-map. Since this is a 3-variable expression, then we'll be needing a 3-variable map. So this is now equivalent to a 3-variable map. Try to consider the arrangement of our cells. 1, 1 comes first before 1, 0 because what we are trying to use is a gray code and not the ordinary combination. Why do we use gray code? Simply because one cell adjacent to its other, there must be only one value that changes. For example, with respect to this, 0, 0 becomes 0, 1. It's only the value for B, which is 0, and it became 1, that changed, and the value for A is still the same. Here, if we put it here, if we try to compare it here, what changes is only the value of A, the value of B remains. Also, with respect to these two cells, that will be the value only of B that changes, and the value of A remains. If we try to interchange these two, if we put here 1, 0, then 0, 1 and 1, 0, that tendency will be the two values will have changed. So please remember that the combination that we are using here is in the gray code form. As in our Boolean algebra, our goal is to simplify the Boolean expression. Here also, in Karnaugh Map, our goal is also to simplify the equation so that the circuit that will be designed will become simpler. So how are we going to do that? We have to follow these rules. How are we going to put our Boolean expression, which is represented also by our truth table, into our map? As I have said a while ago, this is 0, 0, 0. So where is 0, 0? 0, 0, 0 is equal to 1. So we put here 1. 1 is also equal to 1. So 0, 0, 1 here is equal to 1. 0, 0, 1 is also 1. So it's here. Then we have 2. 0, 1, 0. So 0, 1, 0 is equal to this. What else is equal to 1? We have 4 and we have 5. What is 4? 1, 0, 0. Where is 1, 0, 0? 1, 0, and C is 0. So this one is equal to that cell. Last but not the least, number 5. That is 1, 0, 1. So where is 1, 0, 1? 1, A is 1, B is 0, then C is 1. This is that cell. Let's now try to apply our rules in grouping the ones, or what you call the prime in our K-map. So as said in our rule, group only adjacent primes. So where are the adjacent primes? These are adjacent primes, and this one are also adjacent primes. So therefore, can we group these two? So let's try. We try to group these two since they are adjacent. Can we have also this and this? Since this is already grouped together and these are grouped together, maybe we cannot group this one. But we try to consider it, groups can overlap. So therefore, this one can be grouped here and there will be no problem. We have tried to group adjacent primes, but did we use the largest power of 2 raised to n? This one is only 1. So can we group it here using rule number 4 so that we can increase 2 raised to n? We can use 2 instead of 1 only. If we group these two, is it already alright? So we have already done an overlap, but there is still a problem. We have not used the largest power as possible, and with that, maybe the number of groups that we have is not yet the least number of group. Can these two be grouped together? How can it be? They are on the edges. They are not adjacent to each other. But actually, we can group them together by using number 5. That we can wrap around this table, and if we try to look at the values of A and B, that is 0, 0, 0, and 1, 0, actually there is only one value that changes, and that is only the value of A. If we try to group these two, can we use rule number 2? That is using the largest power. How many prime are there? 1, 2, 3, and 4. So 2 raised to n, 2 raised to 2 will be equal to 4. This is possible if we try to group this together. So let's try to group them together. We can see that we have group adjacent cells. We have used the largest power of 2 raised to n. That this one is, we group it by 4. We cannot include this one because there will already be 5 values. And rule number 1 says it cannot be diagonal null if we do that. Let's try now to find what is now the simplified equation that we can obtain in our K-map. Let's try to analyze this group. In order for us to get what is that remaining term due to this group, let's look into what is covered by this group. So looking into this group, covered is this value and this value of A and B. In order for us to retain or to get what is the value that retained with respect to this group, look into that value that did not change. For A, for example, 0 becomes 1. So therefore, it changes. We have to eliminate A. We look into B. B is equal to 0 and B is still equal to 0. Since B is equal to 0 and it did not change in value, then that becomes B prime. Looking into C, however, this one will be equal to 0 and this will be equal to 1. Since this group covers 0 and 1, it means to say therefore that C changes in value. Therefore, we have to eliminate also C. The literal that remains with respect to this group is only equal to B prime, because what did not change in value is this value, which is the value of B, which is equal to 0. That will be ORed with the value of that we can derive from the other group. So let's try to consider this group. Trying to consider this group, it covers these two values, 0, 0 and 0, 1. With respect to these two values, it did not change. A remains as 0, so therefore it is A prime. B did change in value, so we have to eliminate B. This group also can be seen with respect to the value of C that is equal to 0 and cannot be seen on 1. Value of C therefore remains to be 0, and therefore we have to AND that with the first value that we obtained a while ago, which is A prime. So we AND that with A prime. Therefore, the simplified value that we can derive from this group is equal to A prime C prime. The totality of which will be in sum of product. Therefore, the simplified equation now of the summation of 0, 1, 2, 4, and 5 will be equal only to B prime plus A prime C prime. If you want to check this, you can use Boolean algebra and we will arrive to this equation. We have here a notation which states that you can also group the zeros and the answer shall be in pos. There are 3 zeros here. How can we group them together? Can we group these two together? Are they adjacent? Number 2 is grouping by 2's the largest power of 2 raised to n. So since there are only 2 that are adjacent and it's not diagonal, then we can group these two together. Then we can also group these two together. If we group again this one is a single group only, we will have a problem on number 2 because what we want is the largest group possible using 2 raised to n. We group this one and we also group this 2 and we will be able to use all the rules that we have here. We will not be violating any of the rules. We tried to group adjacent primes, okay, but this time it's the 0. We did not group diagonally but only vertical and horizontal. We tried to group using the largest power of 2 equivalent to 2 raised to 1 which is equal to 2. The number of groups that we produce is the least number of groups which is only 2 groups. If we individually group them, the tendency is there will be 3 groups and we'll be violating rule number 2. Number 4 is also used that the true groups overlap together. There is no problem with number 5 because we don't need to wrap it around. Let's try to get now the answer. For this group, it is seen only on this value, that is 1, 1. Since that will be in POS, 1, 1 will be written as sum, and 1 will be represented as prime. So therefore, this will become A prime plus B prime, that is sum. The result of this will be ANDed with the result of the other so that it becomes product of sum. So let's proceed to this other group. With respect to this group, looking into this, what did not change in value is this one, which is the value for B. So therefore, since it's 1, it becomes B prime. Here, C did not change in value also, and that is equal to 1. So therefore, plus C prime. You might be saying, this is different from the previous value that we get a while ago, which is B prime plus A prime C prime. So please remember this value. So how are we going to check that? Again, using Boolean algebra, A prime multiplied by B prime will be equal to this, A prime multiplied by B prime, then A prime multiplied by C prime, plus B prime multiplied by B prime will be equal to B prime, plus B prime multiplied by C prime will be equal to this. B prime times B prime will only be equivalent to B prime. Since there is only a single B prime, let's try to find those terms with B prime. This one and this one. Then let's try to factor out B prime. So factoring out B prime, what remains here will be A prime plus this one will be 1 plus C prime. Then we take this one, A prime C prime, and add it to the other terms where B prime is factored out. A prime plus 1 plus C prime, any term added to 1 will be equal to 1. This will be equivalent to 1, and 1 multiplied by B prime will be equivalent to B prime. Then what remains is B prime plus A prime C prime. As we can see, this one is our answer a while ago using our primes, the result of which was written in sum of product. Remember, our goal is to simplify the equation. Why? Because we want a simpler circuit. If we try to implement this equation, this is the circuit that we'll be needing. A prime, B prime, C prime are ANDed together. A prime, B prime, C. So A prime, B prime, C are also ANDed together. A prime, B, C prime are ANDed. A, B prime, C are ANDed together. And A, B prime, C are ANDed together. And the result of which are ORed together. They are ORed together. And this is the circuit that we'll be needing to implement this expression. However, using our simplified expression, which is K is equal to B prime plus A prime, C prime, this will be the resulting circuit. Definitely, the resulting circuit circuit is much simpler than the original circuit from our original equation. These two circuits, however, will have the same truth table. Remember that our truth table present the relationship between our output and our input. Let's try now to solve Boolean expressions with their don't care conditions. What are don't care conditions? Don't care conditions is that condition where the value of our output can take the value of either 1 or 0. That's why we try to represent it by x. Going back to our equation, that is a prime, b prime, c. Where is a prime, b prime, c? So 0, 0, 1. So 0, 0, 1 is equal to 1. A prime, b, c prime. 0, 1, 0. 0, 1, 0 is equal to 0. Then a prime, a, b prime, c prime. That is 1, 0, 0. 1, 0, 0 is equal to 1. And a, b prime, c. That is 1, 0, 1. 1, 0, 1. That is equal to this. Then we have the don't care conditions. That is a prime, b prime, c prime, which is 0. This is a prime, bc, which is equal to 3. Okay, this condition. And abc, which is equal to 7. And that will be equal to this. Let's try to translate our truth table into our map. 0, 0, 1. So 0, 0, 1 is equal to 1. Then 0, 1, 0. 0, 1, 0 is also equal to 1. Then 1, 0, 0. 1, 0, 0 is equal to 1. Then we have 1, 0, 1. So 1, 0, 1 is equal to this. Then we have our three don't care conditions. That is 0, 0, 0. This one. Then 0, 1, 1. 0, 1, 1. And this one. Then we have 1, 1, 1. 1, 1, and 1. This one. Remember that our don't cares can either take the value of 1 or 0. So since it can take the value of 1 or 0, make it 1 when it will help in the simplification of your equation. Make it 0, however, if it will only complicate our expression. If we are going to use this x and group this one, will it be better than not using them? Why? Because if we will not use them, then these two can be grouped together using wrap around, but we'll be violating number 2, which is using largest power of 2. So if we are going to declare them to be 1, and let's try to group it as big as we can, then it would be better. We can have that as a group. So since we group this, we will also have this group. Maybe we can also have this group. Or better yet, we can have this bigger group together. And we can also have this group. So what did we try to do? We tried to group this together using wrap around and using the largest power that we can have. We group this together using the largest power that we have. And we group these two together. Since we were able to use all the 1 already or the primes already, then it may be already correct. However, there is a problem. It says that we did not use the largest power of 2 raised to n and we don't have the least number of group. Maybe this one is wrong. Why? Instead of using these two only, then we can have it group here. Then we can have increase the power. Let's try to do that. However, there is still a problem. We don't have the least number of groups. Why is it so? We try to analyze again our given. We're already to use all the ones or the primes, 1, 1, 1, and 1. And we try to consider this, the green one, the green group. It can be seen that it is redundant. Why? We can declare x to be equal to 0, and if we try to remove this group, the primes are not affected. See, we have this group covering these primes and this prime, and we have this group covering this prime, and we were able to use the largest power of 2. With that, we have removed another group, and therefore we have a least number of group. Try to solve now for the simplified equation. Try to consider this group, looking again into the value of AB. What did not change is the value of B prime, of B. So it becomes 0 and that becomes B prime. Looking C, again, this is 0 and that becomes 1. Therefore, C is eliminated. What is left is only B prime. Then we OR that to the result of the other group. So this group covers this one, 0, 0 and 0, 1. So it is A that didn't change in value and that is equal to 0. So therefore, it's equal to A prime. Looking again into the value of C, because it covers this and this, and C therefore change in value 0 and 1, so eliminate C. So the result will be equal to b prime plus a prime. Can we use the 0 instead of the primes? Let's try to do that. If we try to use this, then there will only be one group instead of having two groups. Analyzing it, the result will be equal to AB11. Since again it is in product of sum, then that becomes 1, 1, b prime, a prime. It is therefore equal to the value that we can have using sum of products. Do remember that if it is simpler to use the zeros instead of the prime, then we may do that, but the answer must be written in product of sum. Thank you very much for listening, and in our next video, we'll try to have K-mapping for higher number of variables. And please watch also that video.